All right, numbers 13 to 18. So, 13, what is the measure of angle s to the nearest degree? So we got our reference angle s, this is the opposite, this is the adjacent, and this is the hypotenuse. So I don't need the opposite. I'm given the adjacent and the hypotenuse. If you recall, SOHCAHTOA, you'll remember that we need to use cosine here because cosine of theta equals the adjacent over the hypotenuse. And those are the sides I have. And I'm looking for angle S here. So I will get the cosine of angle S equals 60 over 65. So now I got to solve for S, so that means I need to do the opposite of cosine. So I need to do cosine, inverse cosine of 60 over 65 to get angle S. Now, whenever you're looking for an angle, you know you're going to be doing that inverse operation, that inverse trig operation. All right, so let's get the calculator. Show you how to do this. Make sure you're in degree mode. So second cosine 60 over 65, and I get approximately 22.6 degrees. To the nearest degree, that would be 23. So the answer is 1. Okay, number 14. So here's the deal. They actually botched this question, and I'm not going to get into how to solve this right now. What I'll do is, let me just show you the notice they gave the teachers. And then you can also see they botched question 22 as well, and I'll show you the notice for 22 when we get there. But for now, this applies to question 14, and they basically said when scoring this examination, either choice 3, the correct answer indicated on the scoring key, or choice 1 should be accepted and awarded credit. Okay, so number 15, I went ahead and plotted the points RW, and they want us to split it in a 2-to-3 ratio. In order for you to do that, you need to create 5 equal segments. 2 plus 3 is 5. All right. Find the slope of RW and reduce it. That means find the rise over the run. Find the change in Y over the change in X. That means delta Y over delta X. So that's 20 minus 5 over 6 minus negative 4. So 20 minus 5 is 15. 6 minus negative 4 is 10. 15 over 10 reduces to 3 over 2. So that is the slope of the line. So you're going to go up 3 over 2. Up 3 over 2. Up 3 over 2. Up 3 over 2. Now, by you doing that, look at what you just created. You just created 5 equal segments. Isn't that what you wanted here? In order for you to break it up in a 2-to-3 ratio, you needed to create 5 equal segments, and you got them. You got 1, 2, 3, 4, 5 equal segments right there. So now it's just a matter of breaking it up in a 2-to-3 ratio. So let's count. So there's 2 segments here, and then here we'll be left with 3 segments. So that's a 2-to-3 ratio. The point that breaks it up in a 2-to-3 ratio, let's call that point P. What are the coordinates of that point P? The coordinates are 0, 11. So that's the answer to 15. Number 16. The pyramid shown below has a square base, a height of 7, and a volume of 84. What is the length of the side of the base? So let's recall the formula for the volume of a square pyramid. It is 1/3 area of the base times the height. So what am I given? I'm given volume equals 84. I'm given the height of 7, and that's it. So I could use this information to solve for B, which is the area of the base. Okay, it's the area of the base. It's the area of this square right here. So let's replace V with 84, and let's replace H with 7, and we're going to solve for B, for capital B. So let's go ahead and solve. So first, let's multiply this by the reciprocal of 1/3, which is 3 over 1. So that cancels out the 1/3 and the 3. So 84 times 3 is 252. So I get 252 equals B times 7, or just 7B. Let's divide both sides by 7. 7's cancel out. Capital B is equal to what? What is 252 divided by 7? 252 divided by 7 is 36. So that's the area of the base. Okay, that's not the length, that's not the answer. Okay, that's the area of this square. So this square has an area of 36, right? So you got a square that has an area of 36. That means each side must be 6, right? Because 6 times 6 is 36, so the answer is 1. Another thing you can do is just take the square root of 36 to get the side. Take the square root of the area to get the side of the square. Okay, so number 17. The important thing for number 17 is to realize that MS is an angle bisector. So this angle is equal to this angle. And where does that come from? That comes from this sentence right here where it says angle M and angle O are bisected by MS and OR. And so going off of that, we can say the same thing here. This angle is equal to this angle. All right, we got to get very creative with this question if you're going to do it the way I did it. You ready? All right. So for starters, this TMR is 28. Very important. That's 28 degrees, and we know that's going to be 28 degrees. All right, because of the angle bisector, these two are equal to each other. Cool. Awesome. Great. Now, I want you to realize that we got a triangle going on here. This big triangle. And the reason why I want you to realize that is because we're going to use that to find the measure of angle O. So let me just label this O, M, and N. So this is 40. This angle M will be the sum of those 28s. So 28 plus 28 is 56. So let's go ahead and find angle O. 56 plus 40 is 96. 180 subtract 96. What is that? It should be 84 degrees, right? So angle O is 84 degrees. Now, that's angle O. Let me show you something else. You see there is another triangle we can look at here. Triangle OSM. See that triangle there? OSM. Right? Let's focus on OSM. And I'm going to draw that right over here. Okay, that's my best rendition. That's the best I can do. All right, so that's OSM. We know this is 28. SOM, that is actually 84 degrees. Right, that's this 84 I found. Now you can use that to find angle OT. You can use that to find angle S. And we're going to add 84 and 28 and subtract it from 180. So 84 plus 28, 112. And subtract that from 180. 180 subtract 112. What do we get? So 180 subtract 112, we get 68. So that gets us angle S. That's not the final answer. That's this angle right here. Right? That is 68 degrees. But we are much closer to our goal because we got a 68 here, and then we know this guy over here is going to be half of 84. What's half of 84? 42. And the way we're going to find the desired angle, OTS, this is the one they want right here, we'll add 42 and 68 and subtract it from 180. So 42 plus 68, what do we get? Is that 110? It's 110. Subtract it from 180, you get 70. All right, so I know that was a lot. I'm sure there are other ways. If you find another way to do it, please feel free to put it in the comments. I'd love to see it. Number 18, in the diagram below, right triangle ABC has legs whose lengths are 4 and 6. What is the volume of the three-dimensional object formed by continuously rotating the right triangle around AB? So it's saying that we're going to rotate this around AB. So we're going to get a cone. If we rotate it around AB, we'll get a cone that looks something like that. Okay, we get a cone that looks like that. How do you find the volume of a cone? The volume of a cone is 1/3 pi r squared times the height. So it will be 1/3 pi, the radius is 4, squared times the height of 6. So that's 1/3 times pi times 16 times 6. Let's work this out real quick. 6 divided by 3 is 2. 16 times 2 is 32, so I get 32 pi. The answer is choice 1.